Hi everyone, the question is, let lambda be the positive root of the equation x square minus x minus 1 equal to 0 and set an is equal to 1 by root 5 times lambda to the power n minus 1 minus lambda whole to the power n for n belonging to natural number where n is set of natural numbers. Consider the sets set A, set B, where set A has all the natural number n as its elements such that an is a rational number but not an integer, and set B has all the natural number n as its elements such that an is an irrational number. So there are options which suggest whether A and or B are empty and or non-empty. So we have to choose the right option. So here lambda being positive root, clearly you can see lambda is 1 plus root 5 by 2, and 1 minus lambda hence would be effectively the other root, because sum of roots of this quadratic is 1. So 1, if lambda is a root, 1 minus lambda is the other root, which will be 1 minus root 5 by 2. So what about an? An is 1 by root 5 times 1 plus root 5 by 2 whole to the power n minus 1 minus root 5 by 2 whole to the power n. So basically it becomes what? 1 by 2 to the power n multiplied by 1 by root 5 multiplied by 1 plus root 5 whole to the power n minus 1 minus root 5 whole to the power n. Now if n is odd, I mean to say, if in binomial expansion of 1 plus root 5 whole to the power n, if odd power is given to root 5 and same odd power is given to minus root 5, since minus is there, minus root 5 ka odd power would be negative, because minus 1 to the power odd is minus 1, and since minus is there, so it becomes positive. Yeah, so that means the two terms, whenever root 5 is given odd power, the two terms of these two binomial expansion will add. And if you give root 5 even power and the same even power you give to root 5 in the second binomial expansion also, yeah, both terms would be positive, and since there is a minus sign between them and since they are numerically same, they will cancel out. So what I am trying to say is an is 1 by 2 to the power n multiplied by 1 by root 5, and as you use binomial expansion you would get that this expression in this curly bracket is essentially 2 times nc1 times root 5 plus nc3 times root 5 to the power 3 plus nc5 times root 5 to the power 5 plus so on and so forth. Yeah, and this since 1 by root 5 is there, you get 1 by 2 to the power n minus 1. This 2 cancels out in numerator, from numerator 1 2 can cancel out. So 1 by 2 to the power n minus 1, and this root 5 cancels out with a root 5 that you can take common from all the terms in this curly bracket expression, and you get nc1 plus nc3 root 5 square, which is 5, plus nc5 root 5 to the power 4, which is 5 square, so on and so forth. So clearly you can see that an is rational, at least rational, for all natural number n. That means the set B belongs to phi. It is an empty set. Why? Because there is no natural number n for which an would be irrational. You can clearly see that. Now we are sure that an is rational for all natural number n. Now whether there is any n for which an is rational but not integer, let's explore. So for that, let's say 1 minus lambda is mu. In that case, x square is equal to x plus 1 would have two roots. One is lambda and another is 1 minus lambda, which is mu. And lambda and mu would of course obviously also satisfy the equation x to the power n equal to x to the power n minus 1 plus x to the power n minus 2. Yeah, so basically I have multiplied both sides by x to the power n minus 2. Yeah, so you have lambda to the power n is equal to lambda to the power n minus 1 plus lambda to the power n minus 2, and also you have mu to the power n equal to mu to the power n minus 1 plus mu to the power n minus 2. And as you subtract the two equations and divide by root 5, you get an is equal to an minus 1 plus an minus 2. Now if I prove that a1 and a2 are integers, then so would a3 be. Why? Because a3 is a2 plus a1, or rather a1 plus a2. And if a3 and a2 are integer, then a4 would also be integer. Why? Because a4 is a3 plus a2, as per this understanding which we have created. So here, if you see carefully, what about a1? So a1 is essentially, if you put n to be 1, you get 1 by 2 to the power 0, and you are left with just one term 1c1, which is 1, and you get 1. What about a2? You put n to be 2, you get 2 to the power 2 minus 1, which is 2 to the power 1, and again you are left with just one term 2c1, because 2, c3 and all, they would not come when n is 2. So you get what? 2 by 2, which is again 1. So what about a3? a3 would be 1 plus 1, which is 2. What about a4? a4 would be a3 plus a2, which is 2 plus 1, 3, so and so forth. That means, having shown that a1 and a2 are both integers, and having shown that an is equal to an minus 1 plus an minus 2 for all n greater than equal to 3, you can clearly see that all these a1, a2, a3, a4, so on and so forth will be not just rational numbers, but in fact integers. So that means even set A belongs to phi. That means set A is empty set, because an, all an for all natural number n are not just rational number, but they are also integers. Thanks for listening. So here our answer would be A. Stay tuned.